All right, hello young engineers. In this video, we are going to review Python lists a little bit. More specifically, we're going to look at one of the recent assignments, count evens, and decompose that problem and look at a couple different ways to approach solving that puzzle. So we're going to do at least three things. We are going to review and look at lists in Python a little bit. We're going to use that to implement what I would generally refer to as a first semester or fully correct but basic solution. And then really the intent of this assignment was to refactor that solution into something a bit more Pythonic using some of the more recent tools that we have been utilizing in Python, specifically list comprehensions. All right, so notice I'm on CodingBat. Please make sure that you are logged in so it saves your work. Remember that when you're logged in on CodingBat, every time you hit the go button and compile and run your code, it should be saving your work with your profile. So please make sure you're logged in so you can save your work. All right. Also a good time to shout out to Professor Parlante of the Stanford Computer Science Department. Thank you so much for everything that you do, and in particular, not only creating but making available this really excellent tool for exploring and practicing and understanding programming. So again, thank you again, Professor Parlante, for making this possible. All right, so again, we're on CodingBat. All right, so I want to be under Python, and the specific problem we'll be looking at is down under list 2. All right, notice the first one's count underscore evens. All right, so again, what we're really looking at here is CodingBat, Python, and we're under the list 2 section, and the specific puzzle is count evens. So a nice straightforward problem statement here, puzzle. All right, return the number of even integers in the given array. Note, the modulus or mod operator computes the remainder. All right, so we have a nice straightforward one sentence problem statement here, puzzle, which is return the number of even integers in a given array. So we're going to be given a collection or array of integers, and then somehow we need to determine how many of those integers in that given array are in fact even. And then we have this nice specific note here reminding us that modulo or modulus or the mod operator, right, which is operation, is probably going to help us here because modulo or modulus specifically returns only the remainder when dividing by a number. Right? So for example, 5 modulus 2 is 1. Okay, there's our first example. But in terms of how we're actually going to use this, if I have an element I modulus some value, let's say 2, okay, what this is doing, max zoom, what this is doing is saying, all right, my value divided by 2 is going to return what? Remainder. Right? So we're not getting the actual number of times that 2 fits into that value. What we're getting is what the remainder would be had we performed integer division. And the reason that this hint is here is because modulus is the most standard way, programming way to determine if any given value is in fact odd or even. Because we know that odd and even numbers or values, when divided by 2, are going to have very specific behavior. For example, if I were to divide an even value by 2, I should expect that the remainder should be 0. Right? There are no leftover parts. There's no remainder. There's not no remainder. The remainder is 0. Right? The remainder has no value. So I modulus 2 will be returning one of two very specific values, right? Because we're dividing by 2, right, or modulus by 2, the operation is dividing by 2. We have only 2 possible values, right, in that range, and that's 0 and 1. Okay, and so the actual test to figure out if an individual value here is going to be even, right, which is what we're counting, the number of even values, is if I say that the remainder of dividing my value by 2 is in fact 0, right? We make this assertion here to create a Boolean statement. They say that if my element modulus 2 is equal to 0, this statement should be true in all cases where I is in fact an even value, and should be false for all cases where, this is an odd number, right? 3 modulus 2 is going to be 1, 11 modulus 2, any odd value modulus 2 should be returning 1. So by using both the modulus operator and asserting, making it a Boolean statement with this equality, this assertion of equality here, this is our actual check for any value here, I or element of our collection, modulus 2 equaling 0. We know that this behavior is what we should see when the individual element we have from our collection is actually even. All right, and so that's really the operator that we need to test individual elements. But how are we going to apply this test to all of our values, right? Because what we want to do is if we are, if we're returning the number of even integers, so this is a count of elements that satisfy some specific definition or conditional constraint here. All right, so we don't know anything about this array except that it is an array of integers. So we need a way to get through and check the individual elements and then keep track of that check to record them. And so what we really want to do is we want to add structure to this. So we know our check here, well, we don't know, we haven't tested anything yet, but we hope, we expect that this is the check to do for an individual element. But if I want to apply this check to each element in nums, I'm going to need to use some sort of iteration or loop so that I can look at each of those elements. So right off the bat, let's just start with our default for each loop. We know that in Python, we can say that for each element that I find in my collection, do these things. All right, and so this should, again, get us through the entire set of values here. And what we actually want to do for that check is record how many times we find elements that satisfy our constraints, right? So we take our Boolean statement here, this assertion that the remainder of this element will be 0, right? This is our check that whatever is we're looking at here in I is in fact even. All right, so if we found an even number, if we are looking at an individual element from our collection that is in fact even, what do we want to do? We want to update our count. Well, that means we need a place to store this information, right, in this implementation. And so I'm going to give myself a variable here, instance variable that says, all right, the creatively named count is going to store my overall, elements that are even that we've found. And I'll make sure I initialize that to 0 so I don't get some weird behavior, sorry, whatever. So for each of our elements in this collection, if we find that element, this specific element we're looking at for this lap of the loop, right, or this iteration, is in fact even, then we want to record that. Let's say, all right. Just remember here, this compound operator is a way to say take what's already stored in this memory, right, in this reference to memory, take what's already stored here and perform this operator, in this case, add or increment by 1. This is the same thing as in Java or C++, right, doing count plus plus, just increment by 1. Right, and so this is actually most of our problem. However, even if All right, hopefully our implementation here works. If this is all correct logic, so far all we've done is calculate this value, and we haven't actually done anything with it. So once we have calculated, once we've run through the entire collection, if this is correct, then we should have stored, right, in this memory referencer, this variable count, we should have the number of evens stored. So what we have to do, we actually have to return that value we've stored. And so again, this has three main pieces, right? The main part being that how are we going to iterate across this collection? We're going to use a for each loop, right? I want to look at every individual element from that collection, and for each element, if that element is in fact, all right, even, which, you know, we've implemented as if that element modulus 2 is in fact 0, right? If the remainder when dividing that element by 2 is 0, this is even. So we want to include that in our count. And if it isn't, what happens? There's no else here. There's no, there's nothing else in this for loop. So the only thing this loop is doing is pulling each individual element from our collection. On each time it pulls that element, each iteration of the loop, it's got this conditional statement saying, all right, is this an even? If so, let's record it. Otherwise, just keep going until we've looked at all i's. All right, and then again, because this variable, right, exists outside this loop, we should be saving that state or information. And then, again, if this algorithm is correct, turn it. So, all right. So again, as we see, the essential logic, all right, and one possible approach to getting fully correct all solutions. I can look here. I see that we have multiple tests. We got all green. All right. So again, if this were, second quarter, first semester, we'd be done. This would be fully correct solution. But what I specifically asked for this assignment and looking at list 2 count evens was to come up with this straightforward procedural solution, and then again refactor it into something using some of the newer tools or really programming paradigms that we've talked about in class, but that we're trying to get used to and understand how they work. So again, the reason I've asked you to refactor this, even though it's working, is because there's many approaches to solve any individual problem, right? There's many different ways, and I believe that thinking about some of the more Pythonic approaches and solutions is helpful to understanding what's available and what's possible. You are using different tools available to you, and hopefully understanding them. So the first thing I'm going to do is remove this section from the running code. Again, I'm using the triple apostrophe there to create the equivalent of a block comment. Technically, this is a this is a troubleshooting note, but for our purposes, it works the same as a block comment, where this will now no longer be compiled and run. This is human readable at this point. So we have a fresh, technically empty method, but I still can see this information because, again, our approach was not incorrect or wrong. We know this works, so a lot of the elements of this we're going to be able to reuse. But again, we want to refactor it to be a little bit more Pythonic. So again, what we're dealing with here is we're dealing with lists. All right, so we give them this array, and one way to think about this problem is to go through this whole collection that we're given and apply the specific logic of if every element I'm looking at as I get it has this constrained behavior. More accurately, if it's even. If the remainder dividing by 2 is 0, we know it's even, so if it's even, go ahead and count it. This is a very straightforward way to solve this problem, approach it. And again, that's fine, but a different approach would be, well, instead of focusing on the algorithm per element, what if I just focused on getting a subset of this collection I'm looking at that I care about for this problem, right? So instead of focusing on the logical test here, which we know and we've proved is not proved, shown to work, all right? How do I pull the elements I want and create a new collection or list of those elements that are relevant to our problem statement? And what we're really dealing with here is we're dealing with iterables, right? And an iterable is an object that is a collection of things that is able to return those individual elements, one by one or in sequence, right? So sequences are a type of iterables. They're a very common type, and they include things like lists, right, which is what we're working with, and strings and tuples and other, collections of information that are common to use in programming languages. So specifically, we're focusing on the iterable that is a sequence, specifically a list for this implementation, right? And so if I want to create this sublist to deal with, all right, the way to do that is I'm going to take very similar notation here, syntax, for our for loop. I'm going to say this is the exact same syntax as we had for for loop, where I'm saying for each element in our collection are being passed, right? Num is our collection of arrays that are being given or being passed into our function. And then for I and nums, and this will give me actually all of the elements, right? I have no conditional logic. I have nothing for here. So notice by adding square brackets here, this is indicating that I want to create a list of whatever the sequence of elements here, whatever is being returned from here. I would prefer that it was, not prefer, I'm asking for it to be comma delimited as a list in list notation for us to deal with. All right, and this follows off of what is in fact a list comprehension. So one way to think about this is I have all right, and again, this is pseudocode. This is not allowable Python. Probably comment it out. For its own comment. All right, so a basic list comprehension. Again, it's a list because I have square brackets. So whatever's returned by all this is hopefully giving it to me in list comma delimited format. All right, and so the essential fundamental list comprehension is give me this selection, all right, for all of these things in this collection, all right, and a little bit less pseudocode, still pseudocode, but a little more programmatic way to say that is I would like the output, or perhaps even the output expression, all right, for item in iterable, all right, satisfies some condition. All right, and again, pseudocode to try and review some of the things we talk about, or not some, to review how list comprehensions actually are working here. And the idea is that what we actually want, we're defining up front. So our output expression is what we're actually pulling out of whatever collection, right? And again, what we're really doing here is there's many ways to use this tool, right? One of the reasons we're looking at this tool is because it has wide range of application. There are a bunch of extensions here, right? We can put if-else conditions in there. There's a lot of powerful, very specific logic that we can implement by specifically taking what we want from a larger collection. So what does this actually look like? So right now, all right, this is simply going to return exactly what I was given. All right, and not exactly because I was given as an array. It's going to return my array as a list. But it's going to give me every element I, all right, based on I is a member of or is found within, all right, is an element of my collection or array nums. All right, so this doesn't provide the behavior I want, but if we can limit what I'm actually pulling from that collection, all right, and we can limit it in a meaningful way so that, for example, maybe I just pull all of the actual even values out of this numbers, all right, the advantage of this is then we can do whatever we want in terms of operators and, additional logic on that specific subset, all right, that we're really interested in. So instead of just having all elements, all right, from our collection, what if we wanted all elements that were evens? So I can take the same statement we had, right here. We're going to use the same modulus logic, the same operator, and the same Boolean assertion here, all right, to really, this piece right here, all right, to identify even values. So we're not changing the fundamental logic of, we're still want to iterate through our collection, and we still want to apply this conditional constraint of, well, I really only want to know about, all right, I want information related to evens. So I for I in nums, if that element is in fact still even. So we've taken the same logic we had in our for loop and we've reformatted it. And it's not counting. It's actually creating that list of elements that we want to count. All right. And what that means is, with the syntax correct, I now have access to the actual list of values that I care about, not just information about those elements or that list. And again, this is, I don't want to say trivial, but not a major improvement for this particular problem in terms of, time or space complexity. All right, list comprehensions are actually usually quite efficient because, the underpinnings of Python is made to look for patterns and optimize them to a point where usually, they are at least as and often slightly improved performance over your standard for loops. But again, we're not getting a whole lot here because we're doing very similar operators for, again, all the elements. So, but the advantage is, in that same amount of time where we check the specific thing, this specific, aspect of these elements, all right? We're checking the specific action of each element and then doing this count. And then, the only thing we return here is this arbitrary, it's not arbitrary, but this value that we've, decided references this problem. All right. Again, the advantage here is that here we are returning information about our collection. All right. This doesn't actually do anything to the elements. We don't have access to them outside of this loop. All right. All of our fundamental logic in our first approach here is really contained in that for loop. And again, if this is all we're doing and all we ever wanted to do with this collection of numbers, that's fine. But what if, the next problem was, okay, take that same list of numbers you had, instead of, counting the evens, give me the sum of the evens, or give me the sum of the whole list. Or, there's all kinds of, mathematical operations, logical operations we could do here or ask for. And again, if we're actually creating that subset of elements that we care about, all those extensions would be much easier because we have them accessible here. They've been filtered out of our collection. All right, and one of the nice things about list comprehensions is they give us this syntactic sugar, all right, for accessing some very fundamental and important operators, or operations more accurately, like filter and map, and it just really increases the options you can implement and the algorithms, that are possible. So, sorry. So again, default list comprehension, which again, we've seen in class, kind of the pseudocode here for two different options. Second one a little bit clearer here, right? We're providing our output expression, which so far just give me all the elements, right? From item and interval. And again, for each element within nums, all right, that satisfies this condition. In this case, all right, if it's even. So this is going to give us all the even values from our collection, all right, assuming I made any syntactical errors here. All right, so it's going to give us all we're actually creating that list of evens. And again, before I go too far, let's see if this works. Aha! What have I done? If we look here, and again, this is one of the reasons we appreciate and enjoy coding bat, free tests. All right. Notice that what I'm actually returning here, if we look from our examples, right, our expected and our actual, so I'm actually returning the list of evens, which is what we were creating here. So all I actually need to do, or actually we need to do here to get this implementation to work, is instead of giving them that list itself, is simply give them the number of elements in that list. All right, so I can actually pass that whole list we just created. One way to do that is I pass that whole list we just created into the length function, or len function, okay? And again, when we pass a list to the length function, it's going to tell us how many elements or the length of that list. All right, we see that that's actually the puzzle behavior that we were looking for. And one of the goals here is to be able to read through slightly more dense and compact, and I would say expressive, all right, code here. And notice that these perform the same exact functionality for this specific puzzle, but by creating the actual set that we're interested in. All right, we actually have a lot of options. Again, if I instead wanted the sum of all these values, or many other things we could do here, I can simply change the logic we do are applying to that list. Whereas, in this implementation, we'd have to dig into the for loop and change our expressions there. So, and again, this is leading us towards the application of additional functions here, and we want to be working with these tools that are going to help us progress and do more with the language. So again, the basic, straightforward, procedural, again, I would say first semester solution, all right, fully correct, and then again, I would say more Pythonic solution that involves a list comprehension, all right, a selection of elements from that list, specifically by conditional logic, this constraint that we only want the evens, all right, and then simply taking that list we've created and finding the length of it. Two ways to do the same puzzle, all right, and two different ways to think about the same puzzle. So, again, as long as you have both these solutions, all right, and have made an attempt to understand both these solutions, implement them, should be good to go. Please feel free to get back to me with questions on this. But there we go. All right. Again, that was the Python list to count evens puzzle from codingbat.com. Thank you again, Professor Parlante, making this all possible. And let me know how this works out. Let me know if you have problems, questions, concerns. If you have a different implementation, there are many ways to do a similar thing here. Again, we've looked at very briefly, for example, filter. Right? You could use a filter function with a lambda or an anonymous function operator. There are many different ways to do this, but as long as you have both a straightforward and a refactored solution using one of our newer tools, you're good to go. So please let me know if you have any problems. Thank you and good luck.